Let's get started. Alrighty, so you have all of your materials. I'm assuming that's good. If not, you can grab them now. All right, so the first thing we're going to do is balance this equation. So let's go ahead and write this equation down. All right. So we have C3H8 plus O2 yields CO2 plus H2O. All right. So the first thing when we're balancing equations, we have to write the elements we have, right? So we have carbon, hydrogen, and oxygen on both sides. Now what do I do?
We got 3 carbon on the left,
Mm-hmm.
8 hydrogen, and 2 oxygen.
Good job. Now talk to me about the right.
Right, you have 1 carbon,
Mm-hmm.
2 oxygen, and wait, no, 3 oxygen actually.
Mm-hmm. Good catch. Because we have 2 right here and then 1 right here. So we have to add them together. And that gives us 3. Good catch, good catch.
And 2 hydrogen.
Good. All right, let's try to balance this guy. Make sure you're writing in pencil because I think it's going to be kind of messy. All right, who are we going to fix first?
The hydrogen on the right.
Okay, I like your idea, but I always say leave my uh-ohs to the end. So that's hydrogen and oxygen. So I would leave them to the end just because it might make things a little messy. So pick somebody else.
We use carbon.
Okay. All right, so how are we going to fix carbon? So instead of 1, I need how many?
3.
Good job. So the easiest way to do that is times 3, right?
Yeah.
I'll put a big 3 there. Now, mind you, we probably are going to have to erase and redo, but it's okay. So now I need to recount. So I have 3 carbons, 3 times 2 oxygens, which gives me 6, plus this 1 from over here. So that gives me a total of 7. So that's 7 oxygens now. All right, and we're still messed up. So now we can fix our hydrogens. Let's see what that does. What would I need to put where?
A 4 in front of the H2O.
Mm-hmm. That would make what? That's an ugly 4, sorry.
You should have 3 carbon.
Yep. So when I recount, I now have 8 hydrogens, which is awesome. And I have 3, oh, I balanced this wrong in class the other day. 3 times 2 oxygens, which is 6, plus my 4 oxygens there, it gives me how many?
10.
I balanced this completely wrong in class. Like, completely. Glad we're having this moment. Wow, Miss Stanley. Okay. So we have 10 total oxygen. Now let's look at this over on the left side. What do I need to do where? Wow, I really butchered that.
We need 10 oxygen. So counts off.
Good. So I'm gonna put a 5 there, which gives me 10. Wow, I really did butcher that.
What did you do in class?
Okay, so somehow I got 7 oxygens on the right side. So I didn't multiply the 3 times the 2 in CO2. So I did 3 times 1 oxygen. And so that gave me 7 total oxygens. And so I ended up like overworking it by a lot. Like a whole lot. Wow. Okay. Anyways. So you got this part?
Oh, yeah.
Awesome. Yeah. So if you need help with balancing equations, this is for the people who are not in the room right now. If you need help balancing equations, I'll put a link in description for some help videos. Okay. All right, next thing, we need to find the molar mass. All right, finding the molar mass can be fun if you have your periodic table. So the first one we're going to do is C3H8. So starting this week, I don't know, was carbon one of the shorthand ones I taught you guys, or did I make you all do 12.01? I don't remember. But there are some shorthands for the atomic masses. So carbon is going to be 12, hydrogen equals 1, oxygen is 16, nitrogen is 14, and I can't remember the other one I told you guys, but these are the main ones. All right, so we really don't even need our periodic table for this. Lucky us. First thing to do, the molar mass. To find the molar mass, you have to write the elements down, right? So carbon and hydrogen. Now we need to count how many of each one we have. 3 of carbons, 8 hydrogens. Now we find the mass on the periodic table. Carbon is 12, hydrogen is 1. Next, we're going to multiply. 3 times 12 is 36. 8 times 1 is 8. Last but not least, we're going to add. When you add those two together, what do you get?
44.
What was that?
44.
Yup.
Okay.
Yup. Grams per mole. All right, this one's easy. O2, right?
Yeah.
Oh, box your answers. O2, I've got oxygen. And I've got 2 of them. The mass of oxygen is shorthanded. It's going to be 16. That's easy. 2 times 16. 32. Let me not do this in my head, because that's when I make the most mistakes. Grams per mole. Boom. How you feeling about this?
Well, I'm good about this.
Cool. All right, next slide. All right, CO2, H2O. I really feel like we don't need to do these two, but you can tell me if we need to.
No, we're good.
All right. Now this one's a hard one. Can we do this one?
Yeah.
All right. So same process. We're going to write down our elements. Okay. Hardest part about this one is going to be counting. Right. So when we count these, we have to take into account this little parentheses guy. So this 2 is going to multiply into the invisible 1 for nitrogen. So how many total do I have of nitrogen?
2.
Good job. Hey, James. You have 2. We're just working this molar mass problem. If you want to write it down, we kind of just started. Grab you some paper, pencil, all that kind of stuff. We're just working these out. All right, so I have 2 nitrogens, and now we're going to do the same kind of thing, but for hydrogen, right? So we're going to take this little 2 and multiply it times the 4. And so how many hydrogens do I have?
8.
Good job. We do the same thing for the sulfur. So it's 4 times the invisible 1. So it's going to give me how many?
4.
Good. 4 times the very present 2. That gives me how many?
8.
Good. Good. All right, so now I got to bring in my mass. So our cheat sheet says that nitrogen equals 14. I'm going to write in a different color. 14. What's the mass of hydrogen?
1.
Good. What's the mass of sulfur? I'm going to give it to you. It's 32.06. Can't remember if I make you guys say 6.3. I think I say 6.6. Hang on, let me check. 1 second. Sorry. Period table. I say sulfur is 32.066. I was right. All right. Let's keep going. 32.066. And then oxygen. At this point, I multiply across. So 2 times 14 is going to give me 28. And then, there's an 8 there. You just can't see it yet. And then 8 times 1 is 8. 32.066 times 4 is what? What'd you say?
Let me see.
Oh, take your time.
128.264.
128.234.
264.
Oh, thank you. 264. Good. And then 8 times 16.
128.
Good job. Now what do I do?
Add all of them.
Yep. And what do you get?
292.26.
0.264.
Mm-hmm.
Good. Grams per mole. And we box it. That was a good one. How you feel about this still? You still feel pretty good?
Yeah, I'm good on it.
All right, let's keep going. James, if you ever get lost or need to stop me, just holler, okay? Because I'm not really paying attention to the chat, so you have to like unmute yourself, okay? All right, next, we need to talk about going from grams to mole. Okay, grams to mole. This is the whole start with what you've been given, cancel the units diagonally, end with what you need on top, fill in the holes, multiply across, then divide. Do I need to write those steps out or do you guys have them handy?
Well, did you already just refresh?
I got you. So write these down. I'm gonna put it in purple. We're gonna start with given. Then you're going to cancel units diagonally. And then end with need on top. Next, you're going to fill in the holes. And then, number 4. Number 5, you're going to multiply across, divide top and bottom. I'm going to move it, don't worry. And then you're not going to forget your units. I'll move it this whole thing. There. Let me know when you guys have that written down. Okay. All right, here we go. Let's work this one in Pale Pale. All right, it says, given the following skeletal reaction, if I have 36.8 grams of C3H8, how many moles do I have? All right, so first we're going to figure out our given and our need. All right, our given is going to be the number and the compound, okay? So that means our given is 36.8 grams of C3H8. Our need is usually found after how many. So it's like how many blanks. For us, it's going to be how many moles. And it doesn't tell us what to find the moles of, so we assume it's the moles of what we started out with, what we were given, okay? So it's going to be moles of C3H8. We good up to that point?
Oh, yeah.
Okay. So now step one says to start with what we've been given. All right, so our given is 36.8 grams C3H8. Draw a little t-shirt. Step two says to cancel units diagonally. Now, that means that since I have grams of C3H8 right here, what do I have to have in the basement?
Grams of C3H8.
Good job. Oops, that's in yellow. Grams of C3H8. Very nicely done. I just saw a notification. I wanted to make sure it's not you guys. Okay. All right. Now we need to ask ourselves, well, where are we trying to go? What do I need? Well, I need moles of C3H8. All right. Now, we worked out, this managed to be the perfect moment because whenever I have grams involved, I have to have moles of the same compound on top. I have to. So maybe make a note off to the side. When you have grams, so when you have grams, you have to have moles of the same compound in that bracket. Okay. So when you have moles, when you have grams, you have to have moles of the same compound in that bracket. Have to. Okay. So now I'm going to re-ask myself, well, what do I have on top? I have moles of C3H8 on top. I need moles of C3H8, so that means I can stop. Are we good up to that point?
Yes.
Okay. So now I need to fill in the holes. So the main one I have is right here. I have moles over grams. Well, our cheat sheet says that if I have grams over moles or moles over grams, I have to use the molar mass. Okay? Have to use the molar mass. So that means I need to find the molar mass. Okay? So I need to find the molar mass of C3H8. Didn't we already find this one? No.
Yeah, we did. It was
44, wasn't it?
yeah.
44 moles per gram. All right. So this number is going to go right there. 44. Okay. And it's always going to be 1 mole whenever grams are involved. Always. 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 Okay. I can rarely say always in chemistry, but when I can say it, I say it a lot. So it's always going to be 1 mole when grams are involved. Now, how are we feeling? Good?
Good.
Okay. All right. So now we can do step 5. Multiply across, divide by what's on bottom. So I'm going to multiply 36.8 times 1. First, that's going to give me 36.8. Now I'm going to multiply across here, but there's nothing to multiply, so it's just going to be 44. Now I'm going to divide the top and the bottom, and that gives me, I got 0.83636. Okay. I'm not finished because I need some units, right? So my grams cancel out with grams, and I'm left with moles of C3H8. Still not finished because I need to round. So I'm going to look at my question. My question says 36.8, so that's 3 digits. So my final answer needs to have 3 digits. So that means my final answer is going to be 0.836 moles C3H8. I know what you may be thinking. Miss Stanley, does that 0 not count? No, it doesn't. You're just thinking that? The 0 in front does not count. It's called a leading 0. So you start your counting at the first non-0. Okay? So like if I had this 0.000768, this number only has 3 digits, 768. These leading zeros don't really count. We have to put them, but they don't really count. Okay? All right, let's do another one. Right. Grams to moles. Given the following skeletal reaction, boop-de-boop, if I have 24.98 grams of H2O, how many moles do I have? All right, I'm going to start with my given. Maybe. Given. And my need. What is my given?
24.98 grams of
Good job. Good job. And my need. So you're looking for you. Oh, go ahead. So you're looking for the word after how many. That's your keyword. Those are your keywords. How many? So it's going to be moles. Mm-hmm. Good job. H2O. All right. Now, step 1. Do we need our steps again, or you guys have them written down so you're good?
I got them written down.
Okay, perfect. Step 1 says to start with the given. All right, so my given is going to go in my first little block here. 24.98 grams of H2O. Okay. Now, since I have grams of H2O up here, what do I have to have down here?
H2O.
Good job. Still good. Now, since I have, what's this thing called? Since I have grams involved, what do I have to have on top? Moles of the same substance, right? Moles of the same compound. I have to. The reason why I have to is because I can use the molar mass to fill in this hole. But the only way I can use the molar mass is if I have grams of the same compound and moles of the same compound. It's the only way I can make it work. All right, now let's stop and ask ourselves, do I have what I need on top? What is my answer? Do I have what I need on top?
Yes.
Yes, so that means I can stop. So Let's fill in our hole. The only hole we have right here is moles over grams. What can I use to solve this? What can I use to fill in this hole?
Molar mass.
Good job. All right, the molar mass of, wow, the molar mass of H2O. Hydrogen, 2 of those. Oxygen, got 1 of those. It's going to be 16, that's 1. So what's that going to be?
7, 8.
Yep, go through it. What'd you say?
Well, I was going to say 17, but I can't see the numbers.
Oh, you did 17. You did only 1 hydrogen. It's 2 hydrogen. You did 1 hydrogen, and so that gave you 17.
18.
There's 2, so that gives you 18. Mm-hmm. All right, so now I have a hard question. Where does the 18 go? On the top or the bottom?
On the bottom.
Good, good, good. That was really, really good. It does go on the bottom because we have 18 grams per mole. So 18 grams per mole. So how many moles do I have then? Up top.
8.
Close. When there's the mole in grams, it's always, always, always going to be 1.
Oh, yeah.
So when there's molar mass equals 1 mole. Okay. Now I'm going to multiply across. So I have 24.98 times 1. Of course, that's going to give me 24.98. Now what do I do?
18.
Mm-hmm.
Just under it.
Mm-hmm. Now what do I do?
About 24.98. What do I 18?
Good job. I'm so proud of you. All right. I got a bunch of 7s. 7, 7, 7, 7, 7. Okay. So let's take care of our units first. So what's my units for this one?
Moles. H2O.
Good job. So you see how we canceled out the grams, cancel out with the grams, and I'm left with moles of H2O. So now I need to do some rounding, right? Because that's an excessive number.
Yeah.
So let's look back in the question and see how many digits I have.
4.
Yep. So what's my final answer going to be?
1.387. Would you round the 7 or no? Just leave it.
You would round it because the number after the 7 is another 7. So that's going to push that 7 up to what?
8.
Good.
Moles. H2O.
Good job. Look at you work. Look at you crushing it. All right. Let's go to the next one. Because it never stops. Okay. All right, now let's try moles to grams. Guess what? Works the exact same way, except we have to flip some things, but that's nothing major. Okay, so if I have 5.40 moles of H2O, how many grams do I have? Great question. So we start with our given. Let's figure out what that is. Given and our need. All right. What's our given going to be?
5.40 moles of H2O.
Good job. And our need?
Is grams H2O.
Good job. Now I'm going to start with my what?
Given.
Good. Good job. On a little bar. Since I have moles of H2O on top, what do I have to have on bottom?
Moles of H2O.
Good job. Always follow that rule. Don't ever second guess yourself. Always follow that rule. So now, because I have moles involved, I have to ask myself, is what I need, are my need and given the same compound? My need and my given, are they the same compound?
No.
All right, let's look at it. So my given is H2O, right? And my need is also what?
H2O.
Good. So since they are the same compound, I can go into grams now. Okay. Since they are the same, I can go into grams. Okay. So now I'm going to ask myself, am I finished? Do I have what I need on top? What's my answer?
Yes.
Awesome. So that means we can stop. My next step is to fill in the holes. I have grams over moles. So what am I going to use?
Molar Mass.
Good job. All right. And what's the molar mass of H2O?
18.
Good job. All right. So 18 grams per mole. All right. Here's a tough question. Does the 18 go on the top with grams or on the bottom with moles?
Give me the top of it.
Mm-hmm. Because it's got to go with grams. Boom. And now, how many moles are there going to be?
1.
Yes. 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 Good job. Yes. All right. Same thing as always. We're going to multiply across. What do we get?
97.2.
That's what I got. And then we got to do the bottom. And that's just 1. So what do I do now?
97.2 grams H2O.
Mm-hmm. 2 grams of H2O. Do I need to do any rounding or anything fancy?
No.
Nope. Unbox my answer. That was very well done. Good job. All right, next one. Yeah, we're slowly getting harder and harder. Okay. If I have, do I need to go back or are you good?
I'll go.
Okay. All right. If I have 7.60 moles of C3H8, how many grams do I have? All right, here we go. 7, start with my given and my need. All right, my given is what?
7.60 moles of C3H8.
Good. job. And your need is what?
The grams of C3H8.
Good job. All right, so we're going to start with our given. 0.60 moles of C3H8. Oh, since I have moles of C3H8 up here, what do I have to have in the basement?
Moles of C3H8.
Good job. So this is where, now that I have moles involved, this is where I ask myself the question, are they the same compound?
Yes.
And they are, so that means I can have what on top?
Grams.
Good, I see you. C3H8, yes. All right, do I have what I need on top?
Yes.
So that means I can stop. So now I'm gonna fill in the holes. I have grams and moles, so what does that mean I'm gonna use?
Molar mass.
Mm-hmm. The molar mass. I thought we did this one too. Is it 44? Did I make that up?
Yeah, 44.
44 grams per mole. Does the 44 go on top or on bottom?
On top.
Good job. How many moles?
1.
Good. Beautiful. 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 All right. And now, what do I do?
Multiply across the top.
Mm-hmm.
334.4.
Good. So we multiply across the bottom, but one doesn't have anybody, so he's just a 1. Mm-hmm. All right, do I need to do some rounding?
Yes.
Okay, so what's going to be my final answer?
It would be 334.
Yep,
C3H8.
good job.
Oh, yeah.
Wowzers, you just crushed that. Boom. All right, let's make it harder.
No, why not?
That's like the lifestyle of chemistry. Let's just make it harder. Now that you got the hang of it, let's complicate it. All right. So this question is going to go from grams to moles of another compound. All right. So if I have 76.0 grams of C3H8, how many moles of CO2 do I have? All right. Same steps. So we start with our given and our need. Still works the same. So our given is 76.0 grams, C3H8, and our need is moles of CO2. Now I got that because I looked after the words how many, right? Moles of CO2. Now, same steps. I'm going to start with my given. So we have 76.0 grams of C3H8. Now, since I have grams on top over here, what do I have to have down here? Grams. That's a different one. Of C3H8. Now, since I have grams involved, what do I have to have on top?
Moles.
Yep, of the same compound. Okay, now I need to look at the problem, right? Because I have moles of C3H8 on top. Do I have what I need on top?
No.
No. So I have to keep going. So that means that since I have moles of C3H8 on top, what do I have to have in the basement?
Molar of C3H8.
Good job. All right. So this is when I stop and ask myself, because I have moles on bottom. This is when I stop and ask myself, are they the same compound?
Yes.
My need and my given.
Wait, no.
Correct. They're not, right? Because my given is C3H8, but my need is CO2. So since the answer is no, I'm going to use the mole to mole bridge. Mole to mole bridge. Okay. Now, the beauty of the mole to mole bridge is it can get me from the moles of one compound to the moles of another compound, right? Okay. So I have moles of C3H8 on the bottom. On top, I'm going to have moles of CO2. Okay. So now I'm going to ask myself, do I have what I need on top? And what's my answer?
Yes.
Yes. Good job. All right. So this mole to mole bridge up here is going to come in handy in a second. So the next thing I need to do is fill in the holes, right? So let's do this first one. I have moles and grams. So what does that mean I'm going to use?
Molar mass.
Good job. And we know the molar mass of C3H8 by now, right?
Yeah, 44.
Good job. Is 44 going on top or on bottom?
On the bottom.
Good job. And we have a 1 on top. Now, this new guy, I've got mole over mole, right? So because I have mole over mole, I'm going to use the balanced equation. So the mole over mole bridge is going to use the balanced equation. Now, did we balance this equation earlier? Yeah, because that's the one I butchered in class. Yep. So,
Same one.
like, my word, I butchered that. All right, so we would balance this, but we already have it balanced. 3CO2 plus, was it 4H2O? Yeah.
Yeah.
Okay. Thank you. I'm gonna highlight them so you can see them. There we go. All right. So now I need to insert these mole ratios into my chart. So I have for every one, that's not very legible. For every one, yes.
Is that a 502?
Yes, it is a 502.
Where'd you get it?
Okay, so
Is it
when
there?
I balanced, great question, James. When I balanced, can I make a new page? Is that gonna, maybe I should not try to do new things. Okay, so when I balanced this equation, I ended up with, what do we do first? We did the 3 carbons, right? So when I had 3 carbons, that gave me 3 times 2 oxygens. So that's 6 oxygens from that guy. And then I had 4 times 1 oxygens from this H2O. So that gave me 4 total. And when you add those up, you get 10. So the only way to make O2 equal to 10 oxygens is to put a 5 in front.
I got it. Thank you.
Awesome. You're welcome. Thank you for asking. All right. So now for every 1 mole of C3H8, I have how many moles of CO2 using the balanced equation? What you thinking? So I have one of these for every 3 of these. You see the coefficient? That's where I'm going to take these numbers from. So I have 3 moles of CO2. So when we use the balanced equation, we're really going to use the coefficients. Coefficients. Okay? That's what we're using to plug into that space. All right, and now that we have what we need on top, I can stop and do some multiplication. All right, so multiplying across, that's 76.0 times 1 times 3. I got 228. Now I got to do the same thing on the basement. So I do nothingness times 4, T4 times 1 gives me 44. Now I'm going to divide. I got 5.1818. What are my units?
3.
Say it again.
3.
Oh, yes, you're right. Yes. I know what you're saying. Yes. So my final answer is going to be 5.18. Now my units, I'm going to pull from my question, not from my question, but from my crossing out. So I have grams of C3H8 cancels with grams of C3H8. Moles cancels out with moles, and I'm left with what?
Mole CO2.
Good job. And we're going to box that there, boy. Box it. Bam. So, really, we just added 1 bar, right? We just added the 3 moles over 1 bar. There's a lot, but, you know, let's keep going. Continue to make it harder. Okay, next one. Boom. All right, so limiting reactant and excess reactant. This is what we were talking about in class on Friday. So what does that mean? Well, the limiting reactant is going to be the one that limits the reaction. Okay, so we can't make the hot dogs without the buns, and I need a bun per hot dog. So this bun will go with this guy. And you see, I ran out of buns. So he is going to limit the reaction. It doesn't matter how many that I have this extra hot dog. It doesn't matter because I can't make a hot dog without a bun. Okay? So that means that I would be making 4 hot dogs. I would have an excess reagent or an excess reactant of 1 hot dog. He's the leftover. Sad. Okay? So let's apply this to a little chemistry. All right. A 2.80 gram sample of aluminum reacts with a 4.15 gram sample of Cl2. According to the equation below, determine the limiting reactant or the limiting reagent. They're essentially the same thing. Hi. All right, so is our equation balanced?
No.
Okay, is it? Okay, good. We managed to have, let me make sure I do this. Okay, yes, it is balanced. Cool, so that helps out a ton. So this is what we're gonna do. Essentially, we're gonna do 2 grams to mole problems, okay? So the same thing, we're gonna start with our given and our need. Our given for this one, well, this one's awkward because we were given 2 things. We were given 2.8 grams grams of aluminum. And what else were we given?
4.15 grams.
Good job. Of chlorine. All right, now what do we need? Well, we need a product, and we only have one choice for this product. So our need is going to be moles of AlCl3. Okay. Now, the reason why I picked moles is because I could have picked grams, but that would just be one more extra step. Think about it. If I went to grams, I would have to go from grams of aluminum to moles of aluminum to moles of AlCl3 to grams of AlCl3. So that would have a whole nother extra step. So why not just pick the easier step, which would be moles of AlCl3. I'll show you what I mean in a second. Now we're gonna have to work this problem twice. The first time we're gonna do it with 2.80 grams of aluminum. And the second time we work it, give yourself some room, we'll have 4.15 grams of CO2. Now, the reason why we work it twice is because we're trying to see how many hot dogs we're gonna make, okay? So the aluminum would be the bread and the chlorine would be the hot dogs. But either way, I need to see how many complete hot dog sandwiches I can make. So let's find out. Grams of aluminum. If I have grams of aluminum on top, what do I have to have in the basement?
Grams of aluminum.
Good. Now the grams are involved. What do I have to have on top?
Moles.
The same thing. So moles of aluminum. All right. I ask myself, do I need moles of aluminum? No, I need moles of a different compound. All right. So I have to keep going. So I'm going to have moles of aluminum on the bottom because I have moles of aluminum up there. So now that I have moles on the bottom, I ask myself, do I have the same compound? The answer is no. That means that I have to go to the mole-to-mole bridge. Moles of AlCl3. Now, I can ask myself, am I done? Do I have what I need on top?
Yeah.
All right, so I can stop. Let's fill in these holes. Grams and moles, what do I use?
The molar mass.
Good. All right, what's the molar mass of aluminum? Do I need to drop this in the chat for you guys? This periodic table. I put it in there just in case. There you go. For this one, aluminum is going to be 26.982. How many moles?
How many moles? Oh, 1.
Good. All right, now this next one, next door, I have moles over moles. So what does that mean I'm going to use?
Balance equation. Or molar to mole bridge. Mole to mole bridge.
Good. All right, it's my balanced equation. So how many moles of aluminum are there in our balanced equation? Hey, Sammy. We're in the dead middle of a question, but we are almost finished with one part of it. So just hang on tight. Get you some paper, a pencil, and your calculator.
Hey, and okay.
All right, so I have 2 moles of aluminum for my balanced equation, and I have 2 moles of AlCl3 for my balanced equation. Now, what do I do?
Multiply across.
Good job. I'm going to multiply across. Times 1 times 2 26.982 times 2 53.964. I got, I'm writing this in the wrong place, sorry. That's what I get. What'd you get?
Glad to see.
Awesome sauce. All right, so this is how many hot dog sandwiches that 2.80 grams of aluminum could make. Now I need to figure out how many hot dog sandwiches 4.15 grams of CO2 can make. All right, so same process. I have grams of CO2 on top, which means I need grams of CO2 on the bottom. Since grams are involved, what do I have to have on top?
Mole.
Good. Moles of CO2. Now that I have moles of CO2 on top, I don't need moles of CO2, so I got to keep going, which means I'll have moles of CO2 on bottom. So where I ask myself what I'm given and what I need, are they the same compound? And what's my answer?
No.
No. So that means I got to use the mole to mole bridge to get to my needed compound. And I need moles of AlCl3, which means I can stop because that is what's on top. Now I'm going to fill in my hole. I have grams over mole and moles over grams. So what does that mean? I'm going to use the
Molar mass.
good molar mass of CO2, which is CO times 2.45. Is it 453? Check for me. Over there in group 17.
Wait, what did you say you got?
Is it 35.453 or 454? Theo, Corey.
Oh, yeah, 35.453.
Okay, perfect.
Yeah, I did it wrong.
All right, you're good. Then I have 2 of those, so I'm going to multiply that. 70.106 grams per mole. And where do I put that number?
On the bottom.
Good job. And what number? How many moles?
Yeah.
All right, so next door, I have moles over moles. So what am I going to use for this one?
Balance it.
Good job. And now my balanced equation tells me that I have how many moles of CO2?
So 3.
Good.
Yeah.
3. And then how many moles of AlCl3?
2.
Good. All right, so now we're going to do some multiplication. We're going to be multiplying 4.15 times 1 times 2. Do the same thing on the bottom. Right. What did you get?
The same.
All right. So now we get to stop. Lots of work, huh? So much work. But now we get to ask ourselves a fun question. Who is the limiting reactant? Who's going to limit our number of hot dogs we can make? AlCl3. How are we going to figure this out? So who made the least amount of moles of AlCl3? Was it aluminum or was it Cl2? Who made the least amount? Well, let's look over here at our answers. Aluminum made 0.1037. The chlorine made 0.03902. So who made the least?
CO2.
Good job. So the Cl2 is our limiting reactant. Now, it doesn't ask us this, but we can figure this part out too. Who would our excess reactant be? Well, our excess is going to be the guy who we didn't use all of. So that would be aluminum. It's our excess reactant. Okay. Kind of weird. Yeah, lots of work. But it's kind of fun. Sort of. Let's do another one. Ooh. All right. Here we go. This is the one we worked in class. Do we want to work this one or another one?
Let's do another one.
Okay. Let's see what we have. Okay. So this is going to be our question. I'm going to drop a picture of it in the chat because I'm not going to be able to have it pulled up and work it. Okay. Oh, maybe if I do that. Can I make it smaller? Oh. Can you guys still read the question or is it too small?
I can see it.
Okay, perfect. I'm gonna still drop this in the chat for you guys. If you need that question. All right, here we go. Given this skeletal reaction, aluminum bloop-de-bloop, blop-de-blop. If 12.4 grams of aluminum sulfide is reacting with 4 grams of NaOH, determine the limiting reagent. All right, here we go. Dun, dun, dun. Let's start with our given. So I'm going to be over here in the darkness. So our given is what? Well, it's right there, right? So our given is 12.4 grams of Al2SO3. That's one of our givens. What's our other given?
12.4 grams of NaOH.
Good job. All right, now the hardest part is going to figure out what our need is. And literally we could pick either one. We could pick Na2SO3 or we could pick AlO3OH3. I'm gonna pick AlOH3, and the only reason why I'm picking AlOH3 is because that's the first one that's mentioned in part B. But I could literally pick either one. Okay, so my need is moles of AlOH3. Okay. So let's figure out what we need to do. Start with our given. So let's do the first one. So this one is, Miss Stanley, you know good and well you're in round space. I'm going to write down here 12.4 grams of Al2SO33. Okay, why did I pick this one? Because it was the first one I wrote. There's nothing major as to why I picked it. Okay. Now where do I go? What do I have to put in the basement?
Grams of
Good
AL2SO3.
Good job. I wrote this really ugly. Okay. So I have to have grams of Al2SO33. Now that grams are involved, what do I have to have on top?
Moles.
Yeah. Moles of the same compound. Okay. Now that moles are involved, I got to ask myself, are the moles of my given and my need the same compound? And what's my answer?
No.
No. So I got to keep going. You don't stop moving. It's stressing me out. All right. Let's keep going. So I have moles of Al2SO33 at the top, so which means I got to have moles of Al2SO3 at the bottom. Now, since they are not the same, I can use the mole-to-mole bridge to get to the mole of my need. So that's mole of AlOH3. All right. Now, I have moles of Al. My need is moles of AlO3, so I can stop. Okay. So let's go back in and fill in these missing pieces. So right here I have moles and grams. What am I going to use to fill in a moles and grams hole?
Molar Mass.
Good job. So this one's kind of hard. So let's figure out this molar mass. Donovan, figure out the molar mass of this one. And Sammy, figure out the molar mass of AlOH3. Do you feel confident finding the molar mass of AlOH3 or do I need to review that with you? That tells me review it with you. Okay. All right. So Donovan, go ahead and find Al2SO33 for me. So when I'm finding the molar mass, which we don't need, but I'm gonna, because I just realized we don't need that, but I'm gonna do it up here for you, Sammy. All right, so to find the molar mass, which we don't need, everybody please hear me, we don't need molar mass for this one, for AlOH3, but I'm just gonna do this to show how to find the molar mass again. Actually, Miss Stanley, don't be confusing, don't be confusing, don't be confusing, don't be confusing, don't be confusing. We'll just do Al2SO3. All right, so the first thing you're going to do is write down the elements involved. And now we got to figure out the number of elements involved. So I have 2 aluminums, because I'm getting that from the subscript. Find my sulfurs, I got to do 3 times the invisible 1. So once again, that's 3 times the invisible 1 next to sulfur. And that gives me a total of 3 sulfurs. Now for oxygen, I'm going to do the same thing, but it's going to be 3 times the 3. And that's going to give me 9 oxygens. Now I'm going to pull these masses from the periodic table. And aluminum is 26.982. Sulfur is 36. No, it's 32. My bad. 32.066. Oxygen, we round that one to 16. Now I'm going to multiply 26.982 times 2, 53.964. 3 times 32.066. And then 9 times 16. Now I'm going to add. I got 294.162. What'd you get, Donovan?
I got 264.162.
Dang, I got 294. What did I do wrong? Let's see. 53.964. 96.198. 134. I still got 294. You got what again?
I got 264.
Let's see. Let's all do our math again. 26.98 times 80 times 30. 9 times 16. I still got 294. See if you did your math wrong.
There are people outside doing the leaves and stuff, so it's kind of loud. So I can't hear, but I can hear.
Okay. I will try to speak very clear and very strongly. So tell me if there's something you need, okay? Let me know if I need to repeat something.
Okay.
So we found the molar mass to be 294.16. Donovan, check that math again for me. And it's going to be 1 mole. It's always going to be 1 mole when grams are involved. Okay. Next bracket we're going to fill in is mole over mole. Now for mole over mole, I'm going to use the molar bridge, the mole to mole bridge. All right. This one, I'm going to use the balanced equation to figure out. All right. Now look at us with an equation that's not balanced that we need to balance. All right. So how am I going to balance this? I'm going to put a 2 here, a 3 there, and a 6 there. Did that work? Let's see. So I'm going to work it in this. That was unfortunate. I'm very sorry. 1 second. Okay, I'm going to balance this equation over here. Al2 SN3 plus NaOH yields Na2 SO3 plus AlOH3. All right, let's balance this bad boy. In order to balance this, we need to count the elements of each one. I have aluminum, sulfur, oxygen, and sodium, and hydrogen. Aluminum, sulfur, oxygen, nitrogen, and hydrogen. I want to count these. 2 of those. 3 of those. I have 9 oxygens from this guy, plus the 1 here. So that gives me 10. Right? So that gives me 10 of those. Sodiums, I have 1. Hydrogens, I have 1. Aluminum on this side, I have 1. Sulfur, I have 1. Oxygens, I have 3 here, 1 there. So that gives me 4. Sodiums, I have 2. And hydrogens, I have 3. All right, remember, leave your oxygens and hydrogens to the end because they always mess up everything. So I know I'm going to need 2 aluminums. And I know I'm also going to need 3 sulfurs. So I'm going to put a 3 there. All right, let's recount. So instead of 1, I now have 2. Instead of 1 sulfur, I now have 3. Instead of 4 oxygens, I now have 9 from here, 11 from there, and 2 from there. Plus 2 equals 11. I have 11. Sodiums, I now have 3 times 2, which is 6. And hydrogens, I now have 2, 3, which gives me 6. All right, so now I need to fix some stuff on the left side. My nitrogens and then my sodiums are not even. So I'm gonna put 6 out in front here. I need 6 of them. So instead of 6 sodium and 1 sodium, I now have 6. Hydrogens, I now have 6. Oxygens, I have 6 times 1, so that's 6 plus, Lord have mercy, plus my 9. So that gives me 15. What did I count wrong, y'all? Let me see. I feel like I counted something wrong. What did I count wrong? What did you guys get when you balanced this one? Anybody finished with it? I know I did something wrong. Oh, I'm right. I just can't count. Okay, let me figure out how I'm not counting right. Okay. Oh, because I didn't take into account my new oxygens. Okay. So I have 3. That's 9 plus 2. Is this OH3? And Stanley drew her parentheses wrong. That's all it was. He did it right. I just did not copy the problem right. Sorry, guys. Blood sugar's low. 3. So that gives me, what did I not count right? I counted that right. I didn't count my oxygens right. So it's 2 times 3, which is 6. 7, 6 plus 9, which gives me 15. Okay, I did it right. Sorry, that was a lot of jobs for nothing. Back to the problem. Okay, balanced equation. Now I need to plug in my balanced equation coefficient. Sorry about that, guys. Into the equation. I have one of these for every aluminum. Two of these. We're going to multiply across. I get 24.8. And then on the bottom, and we need to end in 4 minutes, guys. On the bottom, I'm going to get 294.6.16. When I divide, I get 0.0843 moles of aluminum hydroxide. All right, now we're gonna do the exact same thing, but with our other given, TBT, okay? So let me zoom and drag. All right, so I'm gonna have 12.4 grams of sodium hydroxide. And grams of sodium hydroxide on the bottom, moles of sodium hydroxide on the top, moles of sodium hydroxide on the bottom. And because I need moles of another compound, I can plug that in here. So moles of my other compound that I need. So AlOH3. Okay. Now I need to fill in these holes. Grams over mole, which means I'm going to use the periodic table. 23 plus 16 plus 1. 40 grams. I know I'm going fast. And then this one, I'm going to use the balanced equation. All right, so I have 6 of these for every 2 of those. Let's do some math. 24.8 over 240. When I divide, I get 0.1033 moles of AlOH3. Okay, so now when I compare those two numbers, I need to figure out who is the limiting reagent. Well, this guy, my aluminum Al2SO, is going to be my limiting reagent because I only made 0.0843 moles of AlOH3. Okay, so my aluminum SO33 is my limiting reagent. My other guy, NaOH, is going to be my excess reactant. Okay. Now, that was a lot, mostly because Miss Stanley can't count the balancing my equations. I'm sorry about that. However, I really do feel like you guys might have a better grasp on what you're doing. Is that true or false? True or false? Do you guys have a better grasp of it?
Yeah.
Yeah? Okay.
Yeah.
Yes.
Okay. Coolio. All right, so I'm going to stop this recording so that it can start processing.